Pluto's that tiny, distant world that used to be a planet. Now, folks like Neil deGrasse Tyson and Michio Kaku are talking about it again. They're wondering if it might crash into Neptune. Sounds crazy, right? But how could that even happen, and what if it did? Is this some weird cosmic accident waiting to happen? Pluto got demoted to dwarf planet, but people are still fascinated. Some experts think Pluto's getting a little too close for comfort to Neptune. Tyson and Kaku are even warning about a possible smash-up that could somehow mess with Earth. So, how could Pluto even hit Neptune? Well, Pluto's orbit is super weird. It takes about 248 years to go around the Sun once. Since we found it in 1930, it hasn't even made a full circle. And get this, instead of a nice, round orbit, Pluto's goes way out, almost like an oval. Plus, it's tilted, about 17 degrees off from the other planets. Here's the kicker. For about 20 years in its orbit, Pluto's actually closer to the Sun than Neptune. So why haven't they run into each other? It all comes down to gravity. When Pluto was first spotted, astronomers tried to figure out its odd path. Unlike the other planets, Pluto's orbit is tilted and oddly shaped. It even crosses Neptune's path. But it hasn't crashed yet. That's because of some tricky celestial mechanics. It's a three-body problem with Pluto, Neptune, and the Sun all pulling on each other. Think of it like trying to guess where things will end up based on where they start and how they tug on each other. Planetary orbits stay stable because of something called non-concurrent libration. Basically, when Pluto crosses Neptune's orbit, they're always at least 90 degrees apart. Another thing is orbital precession. That's when a planet's orbit slowly shifts vertically. For Pluto, when it's nearest Neptune, it's way above Neptune's orbit. Then there's the cool VSK wobbling thing. Some researchers figured out that even though Pluto's orbit looks wild, it stays stable because of how these bodies pull on each other. So, this three-body problem helps us understand Pluto's orbit and how it relates to Neptune. Back in the late 80s, people ran computer simulations that showed even though Pluto's orbit is pretty stable, tiny changes at the start could make a big difference over time. But these simulations also showed that Pluto's orbit stays stable for millions or even billions of years. Neptune's a big deal because it keeps Pluto in a special kind of rhythm. Pluto goes around the Sun twice for every 3 times Neptune goes around. Jupiter's gravity also helps, and even Saturn plays a part. All these things working together keep Pluto on track for ages and away from Neptune. Without these, the solar system would be a mess, with planets crashing or getting thrown out. The whole Pluto-Neptune thing shows how complicated space is and how important it is to study orbits. Even though Pluto's orbit looks jumbled, it's a testament to the careful balance of forces that exist. Space is full of surprises, and Pluto's strange orbit is a prime example. Orbital chaos means that a planet's orbit can change a lot based on where it starts. The simulations help scientists see how Pluto and Neptune affect each other. Even tiny changes can have a huge impact on where Pluto ends up. But, even with all that, Pluto's orbit stays pretty steady over billions of years. It's tough to predict where things will go in space, especially with weird orbits like Pluto's. The models we use depend on knowing exactly where things start. Even a small mistake there can mess up the whole prediction. Besides all the chaos, Pluto reminds us that the universe is always changing. We've learned a lot, but Pluto shows us how much more there is to learn. Seeing how the big planets affect Pluto's orbit gives us insight on how the whole solar system works. So why are the astrophysicists concerned about this potential impact? Neil deGrasse Tyson, a guy who helped get Pluto reclassified, has some thoughts. He thinks Pluto's reclassification isn't a bad thing. Tyson sees space as something where we're always learning and changing our minds. Even though Tyson's upbeat, he still thinks the Pluto-Neptune thing is worth looking at. So, will they collide? Further study will provide answers for us. Maybe it's just a temporary scare. For now, it just goes to show how much we don't know about our solar system. Thinking about Pluto and Neptune colliding makes us think about the mysteries of the universe. How does gravity shape planets, and how about the evolution of the solar system? To understand what would happen if Pluto and Neptune hit each other, consider this: Pluto's surface is covered with nitrogen ice, and its air is mostly nitrogen, methane, and carbon monoxide. Neptune's a gas giant made of hydrogen, helium. Neptune's gravity isn't the only thing keeping Pluto stable. Jupiter's a big player and helps prevent Pluto from venturing too close to Neptune. Saturn makes things more complicated. So, it's unlikely that Pluto and Neptune will collide. The relationship between Pluto and Neptune is not one of a potential impact course. The gravitational connection between them is a barrier that prevents them from crashing. To simplify, Pluto orbits the Sun twice while Neptune orbits 3 times, creating a gravitational dance. The gravitational dance may be broken if any small movements in their path occur. This may be affected by a hidden force like Planet 9 or tidal forces. Continued study and observation of Pluto, Neptune, and Planet 9 are important to understand any long-term shift on their relationship. As technology advances, new data will be available and possibly further adjust the orbital dance between the planets. The discovery of Planet 9. This may have an effect and give an explanation to the Pluto and Neptune interaction. Planet 9 is thought to have gravitational pull that is affecting the other planets. Also, outside forces can affect planetary position. For example, the Sun is gradually losing mass, causing the orbits of the planets to expand over time. As a result, objects passing through, such as comets, may also inflict disruption to the planets. Pluto's trip around the Sun is just plain strange. It takes almost 250 years to go around once. Since we found it in 1930, it hasn't even made one full circle. And get this, it goes in an oval shape, unlike the other planets that go in circles. Its path is also tilted at a weird angle, about 17 degrees, to the rest of the solar system. It's just all over the place. Here's the crazy part: for about 20 years of its trip, Pluto gets closer to the Sun than Neptune does. So why haven't they hit each other? Good question. It's because of the gravity from the other planets. When Pluto was first spotted, scientists tried to figure out its crazy path. The other planets stay pretty flat, but Pluto's is tilted and weird. Even though it crosses Neptune's path, it's still stable. It's like a juggling act in space. Trying to guess where those things will be based on where they are now, and how they're affected by each other. The orbits are all pretty steady cause things kind of balance out. When Pluto crosses Neptune, they're always far enough apart to not hit. Another thing, Pluto's orbit kind of wobbles up and down slowly, which means when it's near Neptune, or any big planet, it's usually up above them, not likely to run into anything. This wobbling thing, some smart folks figured out how planets pull on each other. It keeps Pluto's orbit stable, even if it looks like a mess. So this balancing act keeps Pluto away from Neptune. Back in the 80s, people used computers to see what Pluto's orbit would do. Even though it's usually steady, small changes could make a big difference way down the road. But those tests also showed it stable for billions of years. To really get how Pluto and Neptune work, you have to think about the gravity from those giant outer planets, like Neptune, Jupiter, and Saturn. Neptune's a big deal. It keeps Pluto in a sort of rhythm. For every 2 trips Pluto makes around the Sun, Neptune makes 3. That helps keep Pluto steady. But Jupiter's huge gravity helps, too, and Saturn adds to it. All those helpers keep Pluto on track for a very, very long time, away from Neptune. Without them, things in the solar system would be a mess, planets crashing or getting kicked out. This whole Pluto-Neptune thing shows how complicated space is and how important it is to steady orbits. Even if Pluto's orbit looks nuts, it's a sign of the balancing act that keeps it in place. Space is full of weird surprises, and Pluto's a great example. Thinking about how messy space can be when planets move. Tiny changes can affect its orbit a lot. Computers helps us figure out how Pluto and Neptune pull on each other in space. Small adjustments can affect Pluto a lot. Even with stabilizers, this movement has shown there's no consistency. This apparent chaos is more stable than we expect for billions of years, showing an underlying order. Guessing where things are going in space is really hard, especially the odd ones like Pluto. The natural unpredictability makes it uncertain. Computer models help us, but relying on them can be difficult. Even slight errors can drastically change Pluto's trajectory. Pluto's a message from and about the universe. Space is dynamic and ever-changing. It always has more knowledge to show. Understanding planets' effect gives us more insight on the solar system and how the planet's position impacts and affects the others. So why the concerns about a crash? Well, even with these things keeping things steady, Neil deGrasse Tyson, who, helped make Pluto not a planet anymore, still makes good points about space. These complicated orbits show that we still have so much to learn. Even though he's positive about space, he still wonders about Pluto and Neptune. Will they crash? Or are we just not seeing the puzzle correctly yet? Time and more study will give and show our answers, but for now, we are left more curious and intrigued. The idea of Pluto and Neptune colliding gets us thinking about space and how planets move. If two things that are so different crashed, what would happen? How do things keep the evolution in order? If they crashed, it would teach us a lot about planets and how everything got started. To get the idea of it, we need to consider the characteristics. It's really cold, so things are frozen and iced like nitrogen. Neptune is all gas. If they crashed, they would both change. However, it's important to note that Jupiter's gravitational effect does play a role in preventing this from happening. The outer solar system interactions are not as they seem, preventing a catastrophic clash. Further research has shown the relationship is complex. The resonance is a barrier that prevents catastrophic impact. Described as dancing around each other in order to maintain harmony. Yet the future is not secured. Small shifts can disrupt the resonance, leading to chaos. These shifts occur from other effects like tidal forces from events. Further studies will help us understand the stability. Advancing technology will make things more clear. Planet 9 is believed to have a gravitational pull that could change their current positions. We have to view the overall context of how the solar system is. The Sun is gradually losing mass by solar winds, which expands the orbits of the planets. The outer solar system is not static. Comets are constantly running force in their trajectory. The forces ensures their dynamism by constant shifting as in dance.